Maybe you've heard of them before. Because they are also known as, somebody out there? Yes, exponents. Thank you for that. Exponents. And they look a little like this. Let's just do a ginormous example. 7 to this. Please understand very clearly that this is not 7 times 2. We'll get to that in a minute. This thing right here is called the power or the exponent. Is that really exciting for you? And this one down here, the little big number here, is called the, anybody? That's the base number. This is the exponent. This is the base. And as previously stated here, children, the answer to this is not 14. It is not 7 times 2. It is this. Let's write this down in beautiful words here. The exponent tells you how many bases get multiplied together. You can put double exponent or double exclamation points there. So if you have 7 to the second power, that means you have 2 7s times themselves, which would give you, in fact, 49. Thank you for chiming in there. If you have 2 to the 5th power, the answer to that is, please don't say 10, because that is not correct. It is 5 2s times themselves. 5 2s times themselves. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Somebody out there yelling 64? Was there somebody? Was that you? No. Anybody? Now, a couple special cases here, children. By the way, maybe you've heard the phrase grows exponentially. Anybody know what that means? Exponential growth. Anybody know what that means? Well, it comes a little bit from this, from those of you that care. Let's keep continuing with our 5 here. You know, 2 to the second power is just 4. That's not a very big number, is it? No, Mr. Hahn, it's really not. 2 to the third power is 8. Still not very much bigger. Thank you. So 2 to the fourth power is 16. Well, now it's kind of starting to grow a little bit faster. 2 to the 5th power, we all said, was 32. If I had you guess what 2 to the 10th power is, take a wild stab. Layton, what's 2 to the 10th power? Give me something fast. Why are you quick. Just give me something. 100. 2 to the 10th power. Emily, 2 to the 10th power. What do you think it's going to be? Don't do it. Just tell me what you think it's going to be. 200. 2 to the 10th power. Caleb. 60. Shannon, 2 to the 10th power. Oh boy. Now here, take a look. And this is what exponential growth, this is why you guys are all way off. Let's do it. 2 to the 6th power is 32 times 2, 64. 2 to the 7th power, 128. 2 to the 8th power, 256. 2 to the 9th power, 512. And 2 to the 10th power is 1024. Exponential growth means that something, because in fact you're doubling things here, it starts out growing slowly, but then as you keep going, it starts growing really, really fast, to where you'll get to a point where this gets out of control. 2 to the 11th power is 2048. 2 to the 12th power is what? 4,096. 2 to the 13th power? Somebody? 9,000 what? 380? Something like that. Did I do something wrong there? Somebody's looking at me like I don't know what's going on. That's exponential growth. Now, some special cases. Write these down because you're going to want to know this. This is where people go wrong. Well, no, I guess we should. Now let's do that here. Special cases. How about 5 to the 0 power? 5 to the 0 power is, who wants to take a guess at that? Zach?
0.
It is not 0. That's a great guess. Ulrich?
5.
It is not 5, but that's another good guess. That's where people always something wrong. Leighton?
-5.
-5 is a great guess, but it is also wrong. Incorrect. So far we're 0 for 3. Gianna? What? It is 1. As a matter of fact, anything to the 0 power is 1. Anything to the 0 power is 1. Write that down. Take a little note. Got that? And then the next thing, 8 to the 1st power. 8 to the 1st power is, John?
8.
8. That is correct. Which means anything to the 1st power is itself. Anything to the 1st power. You have just gone up 5 points in your math testing right now, but with this knowledge. Did anybody get the, anybody reach 250 in their maths?
I don't remember.
Yeah.
250?
Anything to the 1st power is itself. Keep that in mind. Those two you need to know for sure. And please also understand this. And when we talk about powers, we have what are called squared. When you say something is squared, and when you say something is cubed. Squared is to the 2nd power. In other words, when I did this, I could have said 2 squared. And cubed is to the 3rd power. We'll talk more about that, but just so you know, 2 to the 3rd power is this. 2 cubed is that. It's the same thing. Cubes and squares. That is like stuffing 5 pounds of potatoes in a 1-pound sack. Anybody ever heard that before? It doesn't matter because you wouldn't answer if you did. We ready to proceed on? Perfect. Now, another blank piece of paper because the opposite, ladies and gentlemen, of exponents and powers is somebody, anybody.
Roots.
Roots. Roots. And roots looks like this. Let's make sure that we get the basic parts of our root system here. This guy right here, he's called the index number. This number underneath the thing there is called the, everybody, you've heard this before, come on, somebody spout it out. Perfect, the radicand. And I know you know what this sign is called, not the division sign, please understand that. This in no way has anything to do with division whatsoever, please don't divide. When you see this little in front of that, it's not the division sign. That sign is called the, tough crowd today. No tough today. Chase, it's called the, it's called the radical sign. Where do you think that phrase came from? That's radical, dude. Right here from good old mathematics. Connor, you said that you say that every day, don't you? Radical?
No.
Have you ever heard anybody say it?
Yeah. No. It means
equal in the 80s. Would you say what? The Teenage Mutant Ninja Turtles, did you say?
I love that movie.
Huh? Nobody's heard this before? And then the gist of this, again, this is not division, right? You have to ask yourself this question to solve this, and there's no magic formula for this. This is only by trial and error. All right, you have to say what number, sorry. What hashtag times itself the index number of times. Actually, that's not the best way to say it. I've never figured out the best way. The index number gives you the radicand. That question up there. That means this. Okay, this little 3, I always do it like this. You don't have to do this, but this is the way to think about it. You want the same number times itself 3 times that will get you this thing there. Gives you 8. Like I said, there is no magic way to do this other than trial and error. There actually is a way to do it, but I don't know what it is. So it's a little harder than 7th grade. So really you try. So you put a 1 in there. 1 times 1 times 1 is 1, that's not going to work. 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So the answer to this, the cube root of 8 is 2. Simply put, it is just 2. Cube root of 8 is 2. Now, generally speaking, a lot of times there is no index number. For example, you just end up with this. Okay, when there is no index number, it's an assumed 2. It's the square root. The square root of 81. Which means what number times itself gives you 81. Anybody out there? Emma Miller. What number times itself gives you 81? You don't have too many choices. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81. It has to be 9. Which leads us to what we call the perfect squares. You have now gone up 6 points on your math test. The perfect squares are the roots that work out perfectly. Roots that work out. How many are there, you ask? Well, technically there's an infinite amount. You get never stopping, but there's not very many in reference to how many aren't perfect squares. But let's look at them. The square root of 1 is perfect because what times what gives you 1? 1. The square root of 4 is 2, right? 2 times 2 is 4. The square root of 9 is 3. You could help me anytime here. The square root of 16 is, thank you, not 18. We're not cutting it in half here. The square root of 25 is, thank you very much. The square root of, should know what I'm going to say. 36 is, the square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12, etc., etc. Though that is the list of the first whatever, 12 perfect squares. They work out evenly. Is nice for you. Which should lead you to ask, what about all those other numbers?
What about all these other numbers?
Well, let's take a quick look at that. What if you had the square root of 75? What is the square root of 75? Anybody? I've got time. Somebody, venture to guess. The square root of 75. Grace? 8 point something is a good guess. Absolutely. This, children, if it's not a perfect square, it falls under the category of what numbers? We've talked about this before. What types of numbers are they called? So say it loud. Irrational. There is legitimately no perfect answer for this in decimal form. It doesn't work out. It's not a perfect square. It will go on forever, as does pi up there. It's irrational. It doesn't make sense. But we can get close to it, which means we do this little squiggly line, which means it's close to but not equal to. And Grace said, what'd you say, Grace? 8 point something? She was guessing 8 point something. Why? Because if you look at our list of perfect squares, where does 75 kind of fit? It would fit right here between the square root of 64 and the square root of 81, which means it has to fit somewhere between 8 and 9. So really, right now, all we can say is it's between 8 and 9. So if somebody gives you the square root of $75, you may get $8, $8.50, whatever it is. I don't know if it's close to 9 or close to 8. Does that not sound exciting? Or what? Oh, wait, I did hear it. Somebody, give it to us. Ooh.
Shake it up, baby, now. Shake it up, baby.
Yeah, I don't know if that was any more intense than the last time. It seems to launch a little life. We should make homework on it. We should make homework based upon how lively or not lively. I'm not feeling it right now.
Yeah. Great, we missed Caleb ruined it.
I don't blame Caleb. Caleb only feeds off the energy you give him in the eyes.
Yeah.
It was lackluster from the beginning. He's not going to feel motivated to do a good shaking up. So what can I say there? Let's look at page 101. Will you look, please? Actually, no. Let's look at page 100. Will you look, please? Are you on page 100? Did we get 100 pages in this book already? Huh. Look at. What's that? What do you think, Cassie? What do you say? And you're sitting right next to it. What? What was it?
Car's not being very smart.
He said it had too much homework. That's why I want to take 100.
And I said, no, that's the only way to get some more.
What do you said what?
That's the only way to get some more if you say that.
Oh, s'mores, yes. Look at example number 6 there, children. It says, the floor. You should be thinking about this whole roots, exponent stuff anytime they mention to you a square, even if it is a shape of a square. That should, right away when you see that, that should turn on some little small switch that turns on some very dim light bulb in most of your heads, that this is what this is about. The floor of a square room, which would be obviously late, and the first thing you do is draw a square room, right? The floor of a square room is covered with square foot tiles. If 100 tiles cover the floor, how long is each side of that room? That means there are 100 tiles there, which means it is 100 square feet. But it's a square. Guess what you are looking for? Here we go. This could be another breakthrough moment for all involved. Okay. You are looking for what number times itself gives you 100. What do we call that? I don't want the answer. What was it when we did what number times itself gives you 100? We are looking for the what of 100? Joseph?
The power or
No. The opposite of that, sir. But you're right on the right track. It's easy to get them mixed up. Chase, we're looking for the,
square root.
yes, you want to know the square root of 100. Because the square root of 100 is what number times what number gives you 100. Or yeah, what number times itself gives you 100. So the answer to this is, every side of that square would have to be 10. The square root of 100 is 10. Now, I don't know if that did anything for you or not, but no, that was your chance. I can't make it up. No, you lost it. Nope, sorry. I can't change that.